finding confidence intervals. Oh, darn it, in space. I'm very upside down and back to front. Why can't I find the right button? There we go. Finally got it. Right, so we're looking at finding confidence intervals. These are the three standard ones. And in question 5, in 2008, they did a poll of 1,100 Americans, and they found out that 9%, which you always write as a decimal when you do the calculations, didn't think the opioid addiction was a problem. So a very small percentage. So in question A, they ask us to find the margin of error for a 95% confidence interval for a poll, for the poll was reported as 3%. So they are telling you that the margin of error was 3%. And we are going to calculate it and see if they told the truth. Well, the margin of error is this bit of the formula, right? These two guys multiplied. That's what we call the margin of error. So for a 95%, which is the story here is a 95% one, we are going to be using 1.96 times the standard error. And the standard error formula is p hat 1 minus p hat all over n. So it's going to be 1.96 times the square root of 0.09 times 0.91, all divided by 1,100. And if things work out right, it should be, at least if you round it off, it should be 3%. So 1.96 times the square root of 0.09 times 0.91 divided by 1,100. And I am not getting the answer. Oh, of course not. Because I didn't read the question correctly. They said the conservative margin of error. Okay. What is the conservative margin of error equal to? It has its own formula, and it's not anywhere near as ugly as that.
Mine just says the confidence interval, the margin of error. It doesn't say conservative margin.
Well, in question A, it does say use the conservative margin of error. So that's what question 5A says here. Okay, so what is the formula for the conservative margin of error?
1 divided by the square root of the number.
Okay, and so 1 divided by 1,100. Let's see how that looks. 1 divided by the square root of 1,100 ends up being 0.030 and stuff. And yep, that is a perfect match to what they said it was going to be. Right. So moral of that story is read the whole question. Right. So part B, on the basis of the reported margin of error, which means that number, let's figure out what the 95% confidence interval should look like, right? Just getting this thing set up. There we go. So it should be 9%. Well, let's put the formula in. It should be p hat. That shouldn't be there. Should be p hat plus or minus the conservative margin of error. I think I got those two because I was rounding those things up. That's empirical when you do that one. So it's p hat plus or minus 3%. And that is 9%. So that's what p hat was equal to. Give or take 3%. So it's 6% up to 12%. And that would be the answer to part B. Then they go in question C, and they want this guy. So in question C, they want this margin of error formula. Since I've already set it up, I'm not going to rewrite that again. I'm just going to find out what the answer is. And this fella is 1.96 times the square root of 0.09 times 0.91, all divided by 1100. And that's 0.0169 and stuff. That's 1.69%, and they want it to 1 decimal place. So wait until you've changed your answer into percentages before you round off to 1 decimal place. Otherwise, if you round off this guy to 1 decimal place, won't the answer be 0? Wait until it's a percentage and then round off. So the last thing you do in a calculation is the rounding off bit, right? You know those questions, I want the answer to 2 decimal places or 5. The last thing you do is that rounding off. Up to that point, as much accuracy as you want, the more the better. Now, based on this margin of error then, the 95% confidence interval is going to be p hat plus or minus 1.7%. And we know that to be 9% plus or minus 1.7. And so it's 7.3% up to 10.7%. Now, when you look at the comparison between the more accurate answer, and that truly is the more accurate, to the kind of rough and ready answer, you see that they are similar but different as well, aren't they? They're in the same kind of range, right? The middle's the same, but isn't this one a lot smaller than this one, right? So if you wanted to be really 95% sure, shouldn't you always use this one? This one here is a good estimate, but I wouldn't bet my house on it. If I had to gamble, I would always use this one, which is why we use these formulas a lot more than that. And for some reason, I put a 2 in there. I think I was thinking of the empirical rule when I did that. You remember 1, 2, 3 standard deviations. I think I was thinking of that. So let's move on to, what was the next one going to be? Question 6, yes. Right, in question 6, they have a new treatment for a certain disease. Very common to do what are called clinical trials, right? You've got a new treatment, a new physiotherapy method, a new pill, a new drug, whatever it might be, and you want to see if it does something good, right? You want to check it. So this new treatment for a certain disease, they did a test and they had 200 volunteers, 200 patients. And it was successful. So whatever it is they did, physiotherapy, whatever the treatment was, 168, it worked for them, which I believe is what, 0.84, because we like working with decimals. That's good. Question A says, find the proportion that it was successful for. Already done it. Question B says, find a 95% confidence interval. So if there's no mention of conservative margin of error, you're always going to be using these guys, right? So this fella is p hat plus or minus 1.96, the square root of these two guys, which is called the standard error. Right. So it's going to be nothing 0.84, give or take 1.96 times p hat 0.84, one takeaway p hat 0.16, all over 200. It's not a great sample, but it is at least in the hundreds. So it's going to be 0.84, give or take, let's see what we get, 1.96 times Square root of these two guys divided by the 200 people who volunteered, and it's give or take 0.0508 and some stuff. And they want the answer to be given as a proportion, so they want decimals. And they also want it to be to 3 decimal places. So here goes. 0.84, take away that guy. And the answer I get is 0.7892 up to 0.84, add that guy. And on this side, I get 8908. And now I will round off to 3 decimal places. Now, if I had rounded off earlier, that might have became 890, and that might have became 788 or 790, right? So if I round off too early, right? If I rounded this guy off, called it 051, for instance, you may have found out that my answer is a little bit less accurate, and then WebAssign says, nope, you got it wrong, which all you really did is, right, you got a digit at the end wrong, but it can be fussy. So since I like I like percentages, isn't this new treatment pretty successful? I mean, if you take it, 79 to about 89% success rate, right? Which is good. But don't you have to compare it against the treatments that are already in place? Right? A 79% success rate is good, but if the other method is a 99% success rate, wouldn't you use the other method? Just common sense. So yeah, that is good, but it doesn't really tell me the whole story unless you can say, well, the other way we did it, the success rate wasn't anywhere near as good as this. In which case the physiotherapy people would be saying, hey guys, there's a new way to treat people who are recovering from, torn ligaments in the knee, right? Instead of doing this kind of exercise, do this other one. And, if it's convincing evidence, that's how we progress historically. I mean, in the past, didn't you use leeches to cure everything? Well, somewhere along the line, somebody figured out that this other way of doing it was better than leeches. And the minute they got enough evidence to prove that that was the case, didn't everybody throw away their leeches and start using other methods, right? Even if it was in the olden days, I'll give you an example because I know useless things. Do you know honey is actually really good at treating cuts and bruises and damaged, scars, right? It's a natural antiseptic and healer. So can you imagine, instead of sticking leeches on the cut, you might cover it with honey and then wrap it up with cloth, and you had a much more successful conclusion, right? Less people died of gangrene, whatever. And so that's how, that's how science progresses. You find a better way, but you have to prove it's a better way. See how you can prove it? Do what we would call a clinical trial. And they always have sentences at the end that you can try and do that. Okay, I'm only picking this one because it's fun. But question 7 says, in a survey of 200 students, 139 of them believe in extraterrestrials. So they believe in little green men. So 139 divided by 200. That is about 69.5%. And it's a pretty classic question. Find a 95% confidence interval. So it's good practice at just using our formula. It's p hat plus or minus 1.96 times the standard error. It's p hat plus or minus 1.96 the square root guy. And then I'll start putting in the numbers. 0.695 plus or minus 1.96 times the square root of 0.695, that's p hat, 0.305, that's 1 take away p hat, all divided by 200. So 1.96 times the square root of 0.695 times 0.305, all divided by 200, and I get 0.0638 and some stuff. And they want the answer to 3 decimal places, that's why I'm writing this to 4. 0.695 take away 0.0638, so we got 0.6312, and then if you add them, you get 695.0638, you get 7588, and to 3 decimal places. And since they're saying proportion, when they say proportion, they want a decimal. And if they say percentage, which is a lot more obvious, based on this 95% confidence interval on a sample size of 200, couldn't we write a little article in our university paper and say, more than half the students at university believe in extraterrestrials? Would you agree that this interval definitely is evidence that more than 50%, right? More than half. If I wanted to, could I push it a little bit further and say more than 60%? Would you agree in this interval? More than 60%. At the other end, couldn't I say it's less than 80%? So you can phrase this interval in different ways. People who are not used to statistics, isn't it easier for them to get a grip around the gist of what's going on by just saying more than 60% or more than half of students believe in extraterrestrials? Don't you get the gist of what the story is going to be about, right? And sometimes you might use the other end, right? Less than 80%. So you could do some about abortion, and you might say less than 70% of Americans believe in abortion, right? Or more than 50% Americans believe in increasing taxes, right? You would use phrases like that. But originally they came from confidence intervals. Are we good? Right. So I don't know if you believe in little green men. I was once an alien. In fact, I used to be called, what was my title? It was a really funny one. A resident alien. I used to be called a resident alien. I think I'm now called a permanent alien. God, they have weird names for us. So I am basically an alien, aren't I? Kinda. Okay, let's do another one of these questions. I'm just scanning through, find something that's kind of interesting to me. The way you're going to do them is very similar, right? It's just practice at manipulating the numbers. Okay, I'm at 10. I might as well do that one next. In question 10, a nationwide poll way back in 2009, the proportion of people who thought that it should be illegal to use a cell phone while driving was 82%. Okay, so P was 82% in the past, right? And in the past, we're talking about a way back in 2009. Now, people's opinion changes through time, right? That's just life. And they said, oh, and they told us that the sample size was 900. Okay. So A, find the value of the standard error. Well, oh, excuse me. P hat 1 minus P hat all over N. 82, 18, all over 900. Square root of 82 times 18 divided by 900. And I get the answer 0.012806 because they wanted the answer to, guess, I would say it's overkill, but they wanted it to 6 decimal places, so there is. You agree that question is just a matter of plug and chug, right? Know what the formula is, plug in the numbers, you got your answer. Move to B. Find a 95% confidence interval. Nothing wrong with that. We've done lots of those. P hat plus 1.96 times the standard error. I know that guy. And it's 1.96 times this ugly guy. And I'm going to cut some corners here. Can you imagine I've done the multiplication, I added, I rounded it off, this time to 3 decimal places. According to what I have here, you end up in that range, right? You just take it for granted, that's what you get. You can do it later, check. Nothing wrong with that. And then they hit us with this guy. A 98% confidence interval. And nope, there is no formula here. Because we are not going to use a formula. If they ever hit you with a confidence interval that is not a standard one, and that's the 3 and only 3s, well, technically there is one more standard one. Anybody want to guess what the last standard confidence interval percentage is? We do a 90, we do a 95, and we do a 99. The last one is typically done when NASA is doing spaceships or nuclear power stations are testing things. So what do you think? That's a really good guess. It's not quite that, but you're darn close. 99.9. Right, now that's not perfect, would you agree? But isn't 99.9 pretty much true, right? You know that whatever you get from that, the right answer is inside it. So how do we use SALT to calculate 97%, 82%, really weird non-standard ones? So let me show you how it works. Okay, I've got all the numbers I want. Yes, I do. So we hit the SALT button. And this guy here appears. And I don't know why it's on that button, but it doesn't really matter. Whatever it's on, I'm going to change it. And I'm going to do where are we going here? All right, okay. Now, pick between, normal distribution, pick between. 0 point, try to get this one right. Where is my numbers? 82. Standard deviation is 0.012806. That's our standard error, right? And we want the between to be equal to 98%. So you make this guy 98. You see, 98 here, mean, standard error here, make sure that says normal. Make sure this says between. So if you've got all these things done, normal distribution, the mean, the p-hat value, the standard deviation, the SE p-hat value, the between, and the 98, your answer is that number to that number. So let me write that down. So it's going to be 0.7902 up to 0.8498. Okay. It's a bit clunky, that, isn't it? You just have to remember lots of little bits on the picture, right? Make sure you're in distribution, make sure it's normal, put the p-hat here, put the standard error here, make sure you're doing a between, and then down here, put the one you want. For instance, you want a 95? That's the only guy I changed. You see the numbers go from here to here, which, by the way, isn't that 795 and isn't that the 845 that we got? Do you want a 99 there? Do you want a 99.9 now? Do you see how you can do it? If you set up everything, isn't the only guy you need to change is this guy? So if you want a 90, a 95, a 99, a 92, a 63, just change that to whatever number you've got.
So on our homework?
On your homework, I really would like you to do it the long way. There are two reasons for that. The first one, it is good practice to get used to how these calculations get done by hand. Otherwise, all you do is I hit numbers and an answer appears, and you're not really getting a good grip of why it works. And the second one's probably much more important. In the final exam, you're going to get these questions. I guarantee it. If you don't show me working, I won't be able to give you any partial credit if you screw up. Right? If you just went into salt and said 42, and it wasn't 42, right? It was 41. Big fat 0 out of 20 points is dangerous, right? So good practice, do it that way. Now, you can't avoid it. You know, if they say to you, I want a 93% confidence interval, aren't you going to have to do it with salt, right? To want a 96, you're going to do it with salt. But if they want a standard one, 90, 95 or 99, do it this way. It's good practice. It's good for you. How are we doing, guys? You comfortable with that? How you can use salt? If you want to, and I don't mind you doing this, see during a test, if it was a final exam, couldn't you do it by hand and then do it with salt? And if the numbers were the same, you've just checked it. That's totally sensible thing to do, right? So use it as a check. Great. Any other questions? We've just done two intervals. There's that one, right? And there's the other one. Which one of these is the wider? Which one is further apart?
Hello?
That one?
Can you hear me?
Cheyenne? Question?
Can you hear me?
I can. So
okay,
which
I
one
was just
of these?
making sure my mic was not working earlier. So
Okay. My question, since you're here, you want to make throw in an answer. One of these two intervals is wider, right? It's further apart than the other. Which one is it?
I want to say that it's the 98%.
And you are right. In fact, in general, won't that always be true that a 99 is bigger than a 90, right? And a 94 is bigger than a 92, right? Bigger confidence interval widens the interval. That kind of makes sense to me. If you want to be 90% sure, you could make your interval this size. But if you wanted to be 99% sure, wouldn't you widen it up a bit more? And that's what that is basically doing. Any questions so far? Are we beginning to feel a bit more comfortable about creating 90, 95, and 99s? Because they're the standard ones. They're the ones you really are going to be doing pretty much all the time, with a few exceptions. Let's give you one to try that. That's a good way for me to check that everything's going good. So this is question 12, my version of it. Suppose that you take a random sample of 600 people who are employed. And in this story, 47 out of 600 said they would fire their boss if they could. So if they were in charge, they would have sacked their boss, right? Find a oops, almost said the wrong number there. I want you to find a 90% confidence interval, right? So use this guy here, 90% based on that information. And you have got 3 minutes to do that. So go for it. No pressure. About a minute to go by my watch.
think I got it.
Oh, perfect timing. Okay, so P hat is 47 divided by 600, which I thought it would be 0.078 and a couple of threes. So this is going to be 0.078 in a couple of threes. Plus
Oh,
or
I just
minus.
Oh, I think I rounded up too soon.
Maybe not. Let's just keep going. It won't matter if it's a little bit out, because at least it means you're doing it correctly. Plus, it does matter how much the question wants you to round it off to. Because, you know, if it wants it to 2 decimal places, it probably wouldn't matter. You get the same answer. But if it was 3 or 4, it might matter. So 0.92167, I believe. And that's over 600. How does that look? Does that look the same kind of roughly the numbers you're using? So that's a good start. So 0.07833 plus or minus whatever that is going to be. So here goes 1.645 times the square root 0.078, couple of threes, times 0.92167 divided by 600. And the answer I get is 0.01884. Is roughly those kind of numbers. We still know, right? So here goes 0.07833. Take away that guy, 0.01884. And I'm looking at 0.05949 up to 0.07833. Add 0.01884. In this case, it's going to be up to 0.9717. And let's say that they wanted the answer to 3 decimal places. So you would get 0.049 up to 0.097. Barring a little bit of rounding off, is that the kind of values that you got?
Yeah,
I got
6.1 and 0.98.
0.0180.
Yeah, I got.
Am I? Because this could be me, not you guys. So does
You
anybody
wrote
see?
a second 8 instead of a 0, so it should have been 0.1804.
Ah, thank you. So that's going to change this one then, isn't it? So 0.07833 add, well, it's actually going to change both, isn't it? 0.01804. And we now have 0.09637. And that changes this guy to a 96. Does that look good? Has that fixed the mistake? I can't hear anyone, so I'm kind of floating here. Yeah, okay. Madison agrees with me. That means this number over here is going to change a little bit. Rather than doing the whole calculation, I suspect it's just the 9 that might change. Does it go 8 something, or does it change in another way? What does this become when you factor in that 0?
I got 0.06D.
Oh, okay, so it's 5, 9, and maybe a number like 8. So that would go 60. Okay, I can handle that. So 6% up to what? 9.6%, which is surprisingly low. I would have thought more people would want to sack their boss. I wouldn't want to sack my boss. He's a good guy. But other people might. Right, I think this is a nice natural starting point because we've pretty much covered you know, there's more examples, but we pretty much covered the same questions. Find a 90 or a 95% confidence interval. Is there anything you want to ask me before we finish off? Any questions?
Yeah, I missed how to do the 98 on the salt because I was trying to do the previous thing on my homework.
Well, you didn't do, are you asking what went wrong with the 98? Not sure what you're asking, Cody.
I'm asking how to do the 98 on the salt.
Okay, let's get that start. You know, you only get one shot at it, so you know it's a bit hard to figure out all the pieces to make 98 arm. So I'm loading it up as we speak. My version might be slightly different numbers, but apart from that, it'll be fine, I hope. God, it's been slow today. Let's try that again. There we go. Which one was the salt one with the 98? What question number was it?
10.
10?
10C.
Well, gotcha. Right, found it. Okay, so I'm going to nip over and just go through it again. Right, so we've got the numbers we want, right? That's 0.81. Oh, darn it. Do you have your standard error numbers? Because I'll need them, and I don't have time to do the whole calculation to find it.
Yeah.
Will you use it? Okay, so we'll use yours. So we'll hit the salt button, right? And you're going to go to distribution calculators, right? That's these guys here. It's going to be normal, right? This guy was 0.8?
Mine's 0.83.
83. So okay, 0.83. And what standard error did you get?
0.012521.
0.05.
No, 0.012521.
Okay. Now you're going to do the between button. You're going to make this number 98, so 0.98. And the small guy is this, right? So it's from 0.08009 up to 0.8591. So these two numbers here are the start and finish of your interval for a 98. This will be the p hat, and this will be the standard error. Make sure it says between, and make sure it says normal. You got all those bits?
Yeah, I was doing the both tails. That's where I went wrong.
Okay, now we know, right? And I bet you there's other people that that's helpful for as well. So that was a good
I
question.
have one quick question.
Sure.
Question 15, when it asks for what is the point estimate? That's just the
P hat.
that's just, yeah, p hat, correct? Okay, yes, that's all.